Bonding. What is bonding? Bonding is the association of atoms to form molecules, compounds, crystals, ions, amongst others. Today, we will want to look at how these molecules and others are formed through bonding. When we look at a periodic table, the universe consists of 100 naturally occurring elements. Just 100. But there are more than a billion differences we can observe with happenings all around us and even happenings within our bodies. All the differences we see are as a result of chemical bonding. The combinations of these atoms through bonds are so vast, we could identify so much difference, even atoms of the same element, but with a difference in the kinds of bonds between them. This involves the food we consume, nature, our consciousness, our very being, and everything else that makes everything else. The answer to the question of why we do not observe just 100 different species in existence, but we observe more, lies in the energy involved in the formation of these bonds and how quantum mechanics play a role in the formation of these molecules. Most of the constituents of air we enjoy are in the form of molecules. Hydrogen, the most abundant element in the universe, is rarely observed alone. It is almost always in the form of a gas. Hydrogen gas. We have nitrogen gas being the most abundant in the Earth's atmosphere, and oxygen being the most abundant element in the Earth. The key to understanding why atoms bond together to form molecules is energy. Most systems are more likely to be in a state of their lowest energy, as explained before. So atoms would like to form molecules in order to attain the lowest energy state possible. A hydrogen atom, for example, has one proton and one electron. The electron forms a cloud around the nucleus. Scientists have been able to figure out that the shape of the electron cloud around the nucleus could be determined using the Schrödinger equation. This is because the electron cloud is a wave function. The wave function gives us an idea of the probability of the result after measuring its properties. Thus, the probability of finding the electron within that region is proportional to the square of the amplitude of the wave function. For bonds to form, there are several things that contribute, and these are the size of atoms, ionization energy, electron affinity, electronegativity. When two hydrogen atoms are far apart, they are both in their ground state, and so nothing much happens. But when these atoms come a bit closer, interesting things happen. The electron of the first hydrogen atom repels the electron of the second hydrogen atom. But the electron of the first hydrogen atom gets attracted to the proton of the second hydrogen atom and vice versa. As these electrons get closer together, the protons of these atoms repel each other, and so these two atoms move slightly apart again. Now, why would they even get attracted to each other in the first place? Shouldn't the electron cloud be repelling each other so they do not get anywhere near each other? The answer to this question lies in the account that the potential energy between the electrons, the potential energy between the protons, the kinetic energy of each atom, the potential energy between each electron and proton. The sum of these energies in quantum mechanics is referred to as the Hamiltonian, represented as capital H. Now, calculating the sum of these energies using the Hamiltonian operator will result in us having a graph which interprets that when these atoms from this point move too far apart, the energy they possess will increase, and when they get too close to each other, the energy they possess will increase as well. So these two atoms will remain in this state, which happens to be the state of the lowest energy according to the graph, where the atoms prefer to be in. So it turns out that the energy of these atoms now combined to form a molecule is less than the combined energy of the two widely separated atoms. This is the reason why the hydrogen atoms are closer together. They would prefer to form a molecule than to move around individually. This sharing process of bonding is called a covalent bond. Now, if we look at the periodic table, study shows that all the atoms that have complete shells, that stable atoms, have the lowest potential energy. All these atoms that have incomplete shells have higher chemical potential energies. The halogens, for example, need one electron to form a stable atom, and so they have a high chemical potential energy, and therefore would prefer to bond to reduce their energy into a lower energy, thus forming a molecule or a compound. So when these halogens react with, let's say, alkali metals, for example, lithium, who also wants to get rid of one electron to become stable, would bind to them, and the result would be a release of exothermic energy, enormous exothermic energy, and thereafter they become a combination with less energy, and this forms the ionic bond. There are other kinds of bonds like the metallic bond, the van der Waals bond, and all these bonds are formed because the atoms would want to be in the lowest energy state possible on their own. So this is the reason why atoms prefer to bond to each other, and this is the reason why we have so many differences we can observe today, and not just 100 naturally occurring elements alone floating around just like that. Otherwise, we won't be having humans or buses or anything possible that we can see today. This answer in a flash. Thank you very much. As usual, like and subscribe. Bye bye.